I probably messed up.
You just do that.
Yes.
I forgot you pressed the answer.
Yeah. But that doesn't mean they're my answer key as opposed to like the answer key from the book means that there's probably 100 people interrupting me while I'm doing it, so there's probably mistakes on it. So don't ever get bogged down if it's one that I did that makes sense. It's mine. They just use that in the mornings during calculus. Thank you. Somebody was asking me about the word if in here yesterday. Who was that? Yeah. Who was asking me? Somebody said, what if the word if's not in there? Does it still do the same thing? I can't remember. Was that you? Yeah. So that doesn't matter. All right, this is 21. So this is going to, because it's between two values and it's linear, that means I'm cutting a line off in this little piece. So it'll be a line segment. Both of them. So, that's right. Thank you, Emma. We have a lesson to get through. All right, -6. I'm going to plug in -6 because that's the first endpoint whenever I plug that in. What do you get? -22. Now I'm going to plug in the endpoint, the other endpoint, and what do you get? 9 minus 4, 5. All right. This first one's going to be closed. The second one's going to be open. Why? The signs. The inequality signs, right? Pretend like this is -6. Pretend like this is -2. 22. This is -6, -22. I'm counting down that thing. And then 3, 5. Does that make sense? To make dollars? Oh. Okay, plug in 3 to this one. I made a mistake on my key. That's okay. I'm sorry. 3, 7. So 3, 7. It's about where that one is. This one's filled in. Then I plug in 6, and I get 6, 4. Oh, that one's open. That's odd. That's odd. This is 6, 4. Domain. -6, that's exactly right. Let's see. 3's included, so I'm going to go to +6. Yep. Go to parentheses. How about the range? What's the lowest it goes? Y value. Bracket or parentheses? Bracket. Why is it a bracket, not a parentheses? And what's it go to? Y value. I'm looking for the furthest right it goes. As I go right, this point is included, so as I go up, I'm sorry. As I go up, 7. So highest it goes is 7. Bracket or parentheses? Bracket, because that one's filled in also. Yay or nay? One. So for the set 1 through 12 at the top, let me just run 1, 5, and 9, so I do one from each. So 1 says f of 2, so this tells me first that I'm referencing the equation f of x, and then I'm going to decide which one it fits. So it says that f of x equals 3 if x is smaller than or equal to 0, and f of x equals 2 if x is bigger than 0. Well, is x smaller than or equal to 0, or is it bigger than 0? It's bigger than 0, so that means this equals 2. The second one says g of 7. So I'm referencing the g equation and, the fifth, yeah, sorry. Number 5. which has two equations, x plus 5 if x is less than or equal to 3, and 2x minus 1 if x is greater than 3. So my question is 7 smaller than 3 or bigger than 3? Bigger. So this is the equation that I use. So 2 times 7 minus 1, which is 13. If you have one. Possibility. It's a very real possibility. Yeah. 20? 20. I gotta graph it to do domain and range, so I'll graph it real quick. F of x equals, mine could be wrong. Is mine wrong? So x is less than 3. 2x minus 4. This is number 20. Alright, so I'm gonna do 3. If I plug in 3, I get 4. Plug in one smaller than 3, so we'll say 2, and then I get 3. This is not a segment. This is more like a what? You don't know what this is called. Array. Open dot, and then 2, 1, 2, 3, this way. And then the second piece, 3, 6 minus 4 is 2. Are both of these explicit? Yeah. 3, 2. So this is going to be an open dot here as well. Bigger than 3, so maybe 4. 8 minus 4 is 4, so I got 4. 1, 2, 3, 4. Domain here, which was the question on this problem, was the domain. As I move left to right, I'm going left forever, so that's negative infinity. But as I truck on to the right, I have a hole in my graph. I have a place where there is no graph. Look at this 3 value here. It's never included. So I need to leave that out of my domain. So I'm going to do negative infinity to 3, and then 3 to infinity. They're both going to be, yeah. And then range is just negative infinity to infinity because it goes down forever, up forever, and there's no spaces horizontally. Do you have a question about this one? Okay, ask it. Look at what it's telling you. This is telling me find one less than 3. So I find one smaller. This is saying greater than 3, so I find one bigger. 24, Sullivan says. And so it shall be. F of x equals x plus 1 when x is less than negative 2. 1/2 x when x is greater than or equal to negative 2. So, ooh. Negative 2, I get what? Negative 1. Now I need one smaller than negative 2, so maybe negative 3. And you get negative 2. This is going to be opened on my starting point. So 1, 2, 3. 1, 2. And, oops, nope, just kidding, I lied. Negative 2, negative 1, and then negative 3, negative 2. Goes in this direction. And then for the last one, if I plug in negative 2, I get negative 1, and then bigger than, so maybe negative 1, and I get negative 1/2. So this point is shared, and that's okay. Negative 1, negative 1/2, and then it goes like this. We're learning about these in calculus right now. Did Rachel right there? Yeah. 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 Yes. Up 1 over 2. Is that right? Yes. Yeah. On the same point. Are you talking about this one? Or are you talking about this one? This one? Every point on the line is closed. Only the end point is either open or closed. But if it's on the line or the segment or any part of it, it's closed. The only ones that are going to be open are going to be if you see a sign without a line under it, and it's just going to be that one point. Other questions? They should be all horizontal because when y equals just a number, it's a horizontal line. So, go ahead. You answer your own question, or are you going to do it? Okay. Oh, sorry, yeah. Domain. Left to right, it goes left forever and right forever, no holes, no dumps, anything like that. So negative infinity to infinity. Range, same thing, bottom up, lowest it ever goes is negative infinity. As you work your way up, there's never any place where you skip any graph. You never have to lift your pencil, so it's just, this is still 24. f of x equals, I have 5 if x is less than 0. I have negative 1/2 x plus 2 if x is between 0 and 2. And I have 1 if x is bigger than 2. These are both horizontal lines at these particular points, but I can still put the points in to show you what happens. For this one, if x is 0, what is y? 5. Pick one smaller than, so maybe negative 1, and y is still going to be 5. 2, 4, well, 1, 2, 3, 4, 5. 0, 5, open dot, negative 1, 5. So this piece goes this way. This one, if I plug in 0, I get 2, and that's closed. This should be a line segment, a diagonal line segment. Then if I plug in 2, I should get 1. So there's that piece. And then another horizontal line, if I plug in 2, I get 1. 2, 1, that's the same point. And if I plug in bigger than, I still get 1. Domain range. So domain left to right, it goes left forever, so that's negative infinity. As I start trucking right, this could be an issue, but that one's filled in, so it's good. I keep going. That one's filled in, so it's good. I keep going. So it's negative infinity to infinity. For the range, though, I start, the lowest it goes is negative 1, and it does include negative 1. And then it goes up to 2, and it stops, and then it picks back up at 5. Because it includes that. Remember, you're looking at the y value, not the x value. So does y actually take on that value ever in the graph? Well, yeah, because this point is negative 1, 5, and it's closing. So it should be 5. Y can be 5 somewhere on the graph. What else? The open dot would impact the domain more than it would the range here. Well, it kind of depends, because if this line had been doing this instead of this, then it would be from negative infinity up to 5 with a parenthesis, because it doesn't include this point. The reason that we have to include it with a bracket is because of all these other places where y has the value of 5. Anything else? Yeah. Ah, you're right. Sorry. What else? Oh, which one? This one? It's not. Is that what the answer key said? Where are you getting 3 from? This? Under? Here? Alright, so that point is 3 is 1. Range looks at Y values, not. Are you talking about domain or range? Domain. So left to right, it doesn't stop there though. It keeps on going. So it goes all the way to infinity. All right. You need a pencil and a calculator. I'm not allowed to do that. This is you. I'm sure you have seen it before. Piecewise. So you have a couple. Yes and no. I don't know if I'm gonna have you graph with the quadratic piecewise. I think we're gonna move on to this, and you might have something to plug into on a quadratic one, but not to graph. All right, here's what greatest integer. So what we're going to do is we're going to start focusing on some parent graphs, and I'll talk to you about what that means a little bit later so that we can do some transformations so that you can do your transformation project. I know that's exciting for everyone. I think it's fun. I have a ton of them, and I laminated them last year, and then I had to clean my walls off, and I don't know where all my transformation projects that were all over here where they went. I got to look. Kenzie put everything up, so I got to ask her where they are because. All right, so greatest integer is a parent function, and here's what it does. This is just an operation that you do to a value. Does anybody know what it does? Not absolute value, this is greatest integer. It rounds everything, close, down to the nearest integer. What's it mean to be an integer? That's right, no decimals, no fractions, everything. So if I told you that f of x equals the greatest integer of x, and this is a function on your calculator. It's under math if you go, I think that's where it is. We don't use it a whole lot on the calculator because it's really not a hard, oh, it's under math and then number and then int for integer. Handy bless you to graph though. But if I asked you what is f of, not x, if f of x is the greatest integer here, what would f of 2.5 be? What would you tell me? 2. It goes down to the nearest whole number is essentially what it's doing, okay? So it's not so hard to figure out what the value would be. How about negative 4.8? Negative 5. Down, so it's going down below. What's down below negative 4? So negative 5. No, this is greatest integer sign. It's a piecewise function. And I'll show you why it's a piecewise function. If I were to graph this, now let's think about it on table here. Let's pick a couple, and I'm going to need to pick some decimals so you see exactly what's happening. So I'm going to go negative 1, but then I'm maybe, instead of going 0, maybe I'm going to go negative 0.5, 0, 0.5, 1, and let's see what happens. If x is negative 1, what do you think y is? This is my equation, y equals the greatest integer of -1. It keeps a sign. It's not absolute value. What if it's -0.5? It's -1 again. What if it's 0? What if it's 0.5? 0, down, always down. What if it's 1? 1. You see what we're getting to here? Let me show you what it looks like graphically. At -1, it's 1. It includes 1, right? So -1, 1. Sorry. -0.5 is still -1. And in fact, all of these values until I hit 0 are always going to be -1. Do you agree? So this is a horizontal line, but once it hits 0, it's not 0 anymore. At 0, it jumps up to 0, right? And then at 1/2, it's still 0. And in fact, all the way until I get to 1, that's when it jumps up and becomes 1. And so the pattern looks this way. Y'all remember these? Sometimes we call them a step function because they literally look like steps as you go. You don't get it? Yes, it's open here because if x is 1, well, y is not 1, y is 1, right? But all the way up until that point, it rounds down to 0. So it rounds everything down to the nearest whole number. Okay, so think of any number, a small number, so we can look at it on the graph. 2, right? Here is x equals 2. What if x is 2.3? Rounds down to 2. Here's about 2.3. It's still at the value of 2, right? What if it's 2.9? Still 2. 2.99? 2. 2.9999999. Still 2. It doesn't jump up to 3 until x is actually 3. Well, all these points are on here. -1, -1, -1, -1, -1, -1, -1, -1. And in fact, I could put more numbers in here. I could say -0.2 is still -1. -0.1 is still -1. So all of these values here of x still go to -1 for y. And then they jump here. You always round down the decimals, yes. Correct. Well, remember, it's a function. So I can't have two different values here. When x is 1, I can't have two different values for y. When x is 1, y is 1. That's the point where it jumps up to the next value. This point is 1, 0. Is that true? If you plug in 1, it's not, because that's not a point on the graph, right? When x is 1, what is y? 1. It's not 0. So that's why it jumps up here and becomes 1, 1, not 1, 0. Yes. But now we're going to do stuff with this. It's not going to be just, yes, yes. We have to do enough to pick up the pattern, find where it's jumping. So let's start plugging in some values. Specifically, probably some decimal values because I know it's got a greatest integer function in here, and that's where crazy things are going to start happening, right? So let's go, I'll do a whole number. Let's do the same ones first and see what happens. If I put a -1 in, I know that this is going to be -1, and -1 plus 2 is 1. And these are all actual points. They're not holes or open circles. -1, 1. How about -1/2? At -1/2, this becomes what? -1 plus 2, it's still 1. What happens as I get closer and closer to 0 here? Is this value going to still stay the same? Look, how about if it was 1/4? -1/4, I mean. Still the same, right? -1/4 plugged in here. This still is going down to 1. Or -1. And -1 plus 2 is always 1. So all the way up. But what happens at 0? It jumps. This is where it jumps. It becomes 2. Everybody see that? Jumps at 0, it jumps up to 2. What happens at 1/2? It's still at 2. It's still there at 2 because if I put 1/2 here, that still becomes 0. It always rounds down. And in fact, all the way over until I hit 1, because at 1, what is my y value? 3. This is where it jumps. Now I think I have enough to pick up the pattern. This would continue in the same manner. Okay, what's the domain? There's never any place where I don't have an x, do you agree? Even though I'm jumping right here, this x value is still defined here. And then I go this way, and this x value is still defined here. So the domain is -infinity to infinity, but what about the range? So what am I leaving out? Not odd.
Good morning, Cameron Hines. Please stand for the Pledge of Allegiance.
You're right.
I pledge allegiance to the flag
Of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Please receive the amendment. Attention Spirit Club members, we have a very important meeting today during the last few minutes of both lunches in the Commons. Attention students interested in the Air Force. On Thursday during both lunches, there will be a representative from the U.S. Air Force in the Commons. All students with questions about how the Air Force can help them become college and career ready should consider stopping by to find out more information. In sports today, swim team hosts Blindwood, JV and varsity volleyball hosts AC Forum, and the JV Mets at 5:30 and varsity to follow. Cross country travels to Thomas Upchurch. The varsity volleyball team had a great win versus Gilbert last night and battled with a strong Gray Collegiate team. Avery Iyer continues to lead in assists. Avery and Peyton Sanders were our